We are on to our last quadratics lesson for this particular year. We are looking at solving problems involving quadratics. Now remember, we summarized on a big sheet of paper, we summarized how to find the y-intercept, the zeros, the vertex for the factored form and the vertex form before we left for March break. When we do this, you could take your information from here and add it to that large sheet if you want to keep that for your following courses. All right, first of all, to get the x-intercepts from the standard form, we can factor if possible, and then set each factor equal to 0 and solve the mini equation. So if you have that standard form, so for example, if you had y equals 2x squared minus 13x, and then plus 15. So let's say that's the function that you want to find the x-intercepts of. You would set that y equal to 0, and then you would try factoring this. So it's a trinomial, there's nothing common to factor out. I'd be looking for two numbers that add to negative 13 and multiply to positive 30. Remember that positive 30 comes from multiplying the 2 and the 15 together. So I think negative 3 and negative 10 will get a positive 30 and add to negative 13. Now I'm going to put the 10 and the 2 together. So I'm going to rewrite this as a 2x squared minus 10x, and then minus 3x and a plus 15 here. And then out of that, we pair them up for a common factor. So if I look at this first pair, I could common factor a 2 and an x. And when I divide both those terms by 2x, I get an x and a minus 5. If I look at the second pair, I can divide both of those by 3. And I know I want a positive x here. So that means I have to have a minus 3 to go with that. So minus 3x divided by minus 3 is the x, and then positive 15 divided by minus 3 is minus 5. Now that sets this up that these are the same, so we're going to common factor those. So x minus 5 is common, and when we divide the two terms by that, we are left with a 2x and a minus 3. So now we have the factored form. What we do is we set each one of those factors, so one of the factors was x minus 5, we set the factor equal to 0. Our other factor was 2x minus 3. We set it equal to 0. And then we solve these little mini equations. I'm going to add 5 to both sides here and get x equals 5. I'm going to add 3 to both sides. We get 2x equals 3, and then divide both sides by 2. X equals 3 halves, or 1.5. So that's how we can get our x-intercepts here. X-intercepts then would be 5, 0, and 3 halves, 0. All right, now if it won't factor though, this won't work. And for those of you who don't have great factoring skills, you could always go into that quadratic formula. So our quadratic formula is that x equals negative b plus or minus square root b squared minus 4ac, all divided by 2a. Okay, so for example, if you had the relationship, let's go with 3, let's make that a negative. Negative 3x squared plus 7x minus 2. If that was our question, and we wanted to know where that was equal to 0, or we wanted to find if that was a y instead of equal 0, if it was equal to y, we'd be finding the x-intercepts. We're going to figure out our a, which is equal to negative 3, our b, which is 7, and our c, which is negative 2. We're going to put that into our formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times the a. And then I'm going to put what's in the square root into my calculator. I'm going to write it with that simplified and go from there. So we ended up with a square root of 25, which actually we can take the square root of 25 and get a nice answer of 5. And then we break that into the two pieces. We've got one piece here where we're using the plus 5. We've got the second piece over here where we're using the minus 5. And simplified form, either x is equal to 1/3 or x is equal to 2. So those are our two answers there for that one. It's possible that you'll end up with decimal answers, especially if that square root is not going to give you a perfect square under the square root sign. So that's our goal there with solving for x-intercepts. Again, if you're not so great with factoring, go with the quadratic formula. To get the vertex from standard form, we can complete the square, which is optional. I made it optional just because of our circumstances this year. But I'm going to show you another way to come up with the vertex from that standard form. All right, so I will do an example here with completing the square, and then I'll show you the shortcut. All right, so I have my example of y equals 2x squared minus 12x plus 15. Step one for completing the square is to pull out the a value from the x squared and the x term. So I've divided that out. The x's stay though, even though it looks like a common factor, we're going to keep those x's there because we want to be able to build that as a perfect square. To get the perfect square value, we take half of that b term, so half of negative 6 would be negative 3, and then we square it. Squaring 3 would give us 9. We're going to add 9 and then subtract 9, and we still have the plus 15 on the side here. And then we're going to kick the minus 9 out of the bracket. So the plus 9 completes the square. The minus 9 doesn't belong with it. To kick it out, I'm multiplying the 2 and the minus 9 together to get minus 18. And then our last step here will be to factor that perfect square. So that's going to be x minus 3 all squared. And minus 18 plus 15 would be minus 3. So the vertex here, or this would be a minimum, vertex would be at positive 3, negative 3. Remember, we switched the sign on that x value to write the x coordinate of the vertex. Now, I'm going to show you that this also works. I could take my example that I have here, my y equals 2x squared minus 12x plus 15. I know from the factored form, if I were to find the midpoint of our zeros, the midpoint of the zeros would give the x coordinate of the vertex. Now I'm going to show you something here. I'm going to identify the a, b, and the c. The a is the coefficient of the x squared, the b is the coefficient of the x, and the c is the constant term. We're going to calculate x equals negative b over the 2a. So negative b would be negative 12, negative 12, and then that's going to be divided by 2a. That gives me positive 12 divided by 4, and positive 12 divided by 4 is 3. So you'll notice that that 3 matches with our x coordinate of our vertex. So that was why I said we'll do the completing the square. It's an important skill to have if you're moving on, but if you're not going on into advanced functions or MCT4C, you're not going to need that there. This is my x coordinate. Now that I have my x coordinate, I'm going to sub that value of x into my original equation and solve for the y. So I'm going to put my 3 in where the x is, into that equation, and then just pop that into the calculator and it will give you the y coordinate. So if you check that, you should get a 3 out of that. So your vertex, the maximum value is 3 when x equals, sorry, that should be negative 3. I copied it down wrong from my calculator. So our vertex is at positive 3, negative 3. So a nice easy way to come up with the vertex from our standard form. So we use these things when we're solving problems and putting these into context. So you can add this to your summary sheet that we had started earlier in the semester. But just remember these key ideas when you go to solve problems. Your y-intercept would be questions like what's the initial height, the starting value, the height that the rocket was launched or the ball was thrown from. Your zeros, so when you think of your parabolas, let me do something like this. So there's your initial height right there, your y-intercept. Your zeros are where your height would be 0. Or we also, when we talked about our profit questions, the break-even points are where the profit equals 0. So we're looking for the x-intercepts for our values there. When does the ball reach the ground? So think of the graph with that. For the vertex, if we're asking for what the maximum height of something is, we're looking for that y coordinate. We're looking for the time it reaches the maximum height. We're looking for the x coordinate. We talk about maximum profit. We might have a cost question where we're looking for the minimum cost, because our cost function will probably look something like that. So all of these things you might want to add to this types of questions as you do your assigned work, to remind yourself of different types of questions and what it's actually asking for in terms of the characteristic of a parabola.